Hello everyone. Welcome to today's class on chemical reactions and equations. Today we will be discussing about types of chemical reactions. Before doing that, we will briefly discuss as to why do we get different chemical substances when a chemical reaction takes place. So what exactly happens when a chemical reaction takes place? When a chemical reaction takes place, try to understand that a new atom is not formed, a new element is also not formed. So, what exactly happens? But you definitely get a new substance. This happens because the bonds or the attractive forces which are present in the reactants, they break and some new bonds will be formed. So when new bonds are formed, what actually happens is the rearrangement of the atoms present in the reactants. So the new substance you get not because new atoms or new elements are formed. You get a new substance because the rearrangement of atoms take place, which means the atoms and elements which are already present, they undergo a rearrangement to get a new substance. So let us observe some reactions to understand different kinds of chemical reactions. So over to the reactions. We have already seen this reaction, the burning of magnesium ribbon in oxygen. You know what happens? Magnesium is reacting with oxygen to produce magnesium oxide. We will discuss it in detail after seeing the other experiments also. Now in the next experiment, you can see we have taken a little lime water in a beaker and we are blowing air through it. You can see the change of color, and that is because of calcium carbonate. Now in the third experiment, what we do is we pass electricity through a little water taken in a tumbler, as you can see. Now those two test tubes are connected to the terminals. They already contained water. Now you can see some gas is getting formed. You know those gas which are formed are hydrogen and oxygen. Now let us discuss all these reactions in detail. The first reaction you have seen is magnesium reacting with oxygen, and it is giving you magnesium oxide, as you already know. Let us balance the reaction. It is 2 Mg plus O2 gives 2 MgO. So MgO is the product. And you can see we have a single substance formed as a product from two different reactants. So which are the reactants here? Magnesium and oxygen. So we have more than one reactant. The reactants are magnesium and oxygen, and you get a single product which is magnesium oxide. See the next example. Suppose we burn carbon in oxygen exactly the same way magnesium is burned. Carbon dioxide will be the product. Here again you can see there is a single product formed from two different reactants. The reactants are carbon and oxygen. The reaction is already balanced, as you can see. The next reaction which we have observed just now, we passed carbon dioxide through lime water taken in a tumbler. Here we are taking calcium oxide. So calcium carbonate formed as a result of this reaction. So here also you can see there is a single product which is calcium carbonate from two different reactants. Same way hydrogen reacts with oxygen to produce water. Let us balance the equation. 2H2 plus O2 gives 2H2O. Here again you have a single product which is water from two different reactants which are hydrogen and oxygen. So what you see in all these reactions is from more than one reactant you get a single product. Such reactions are called combination reactions. As the name indicates, combination means combining of two or more reactants to produce a single product. So there will always be more than one reactant and product will be a single product. That is what a combination reaction is all about. Now let us discuss the other experiment which we have observed, the electrolysis of water. Electrolysis of water means passing of electricity through water. We have seen when electricity is passed, you get two gases in two different test tubes. If you have doubts, you can go back to those reactions and see again. Now here what you can see is there is a single reactant which is water. Now when electricity is passed through it, it gave you two different products, hydrogen and oxygen. You also must have realized that the volume of hydrogen is twice the volume of oxygen. You can see the reaction once again if you want. Now this particular reaction is not balanced right now. 2H2 should give you 2H2 plus O2. In the next equation you can see calcium carbonate is giving you calcium oxide and carbon dioxide. Here also you can see calcium carbonate which is called limestone, which is a single substance. It undergoes decomposition or breaking down to produce calcium oxide and carbon dioxide. So hope you have realized that this is just the opposite of what happens in combination reactions. Another reaction, FeSO4 on heating strongly, it breaks down to produce Fe2O3, ferric oxide, sulfur dioxide and sulfur trioxide. Here also you can see one substance which is the reactant, which is ferrous sulfate. It undergoes decomposition, means breaking down, to produce the products Fe2O3, SO2 and SO3. More than one substance is formed as products. So one more reaction, let's see. If you heat lead nitrate, lead nitrate is PbNO3 twice. Heat strongly, it will get decomposed to produce lead oxide plus nitrogen dioxide plus oxygen. Here again you can see you have more than one product, whereas it is formed from a single reactant. Another example, if you expose silver chloride to sunlight, this will become gray in color because of the formation of silver. And here again you can see the silver chloride is undergoing decomposition. It is giving you silver and chlorine. So silver chloride turns to gray if you expose it to sunlight. Silver bromide also undergoes the same reaction, exactly the same reaction. Silver bromide would have given you silver and bromine. And this is the principle of photography also. So you can see silver bromide giving you silver and bromine. It should be 2 AgBr. I think it is not written 2 AgBr, you can correct it. So single substance undergoing decomposition to produce silver and bromine. And such reactions are called decomposition reactions. A single substance breaking down to produce more than one product. Such substances, such reactions are called decomposition reactions. So we have learned two types of reactions: combination reactions and decomposition reactions. Now let us discuss about exothermic and endothermic reactions. Suppose A and B are two reactants, and if they react to produce a product C, and in the process, if heat is generated, so because of the reaction, heat comes out. Such reactions are called exothermic reactions. Whereas if P and Q, if they have to react and we need to supply heat, in that case heat is absorbed by the reactants, and such reactions are called endothermic reactions. Now let us take a few examples. When methane is burned in oxygen, methane gives you carbon dioxide and water. Along with carbon dioxide and water, you also get heat. Methane is a fuel. It burning or combustion, it gives you carbon dioxide and water and also a lot of heat. This is an example of exothermic reaction because heat is generated. Similarly, the other day we had seen this reaction, zinc reacting with the sulfuric acid, producing zinc sulfate and hydrogen. If you touch the sides of the conical flask where the reaction took place, you would have felt the conical flask hot because heat is generated in this reaction. So this again is an example of exothermic reaction. Now let us see a few examples of endothermic reactions. Endothermic means we need to supply heat for the reaction to take place. Such reactions are endothermic reactions. We've learned so many examples already. If you can remember, calcium carbonate, which is limestone, is converted to calcium oxide, which is called quicklime, by heating it very strongly. So for this reaction, we need to supply heat. Therefore, it is an endothermic reaction. You can find out more such examples. Lead nitrate on heating gives you the products. Find out more examples. That's all for today's class. See you in the next class.